Hey everyone, so today we have a self employed game developer from South Carolina hopping in and doing a leak code coding interview. Um, yeah, so could give a quick background on yourself? Like, that's
Yeah,
cool.
sure.
You do game development?
Yeah. So I previously worked at Amazon, and then
Nice.
I worked as or I worked at a startup for a year, and then I decided to try doing game dev. I'd always done it as a hobby like the past 7 years or so. Um, Currently working on my second Steam game, but I wanted to get back into Fang or some normal job. So back to doing leak code.
So you graduated 6, 7 years ago? You're pretty close.
4 years ago.
Okay, nice, nice. Which school did you go to?
University of South Carolina.
Nice, nice. They have a really good basketball team for women's. Um,
Yeah.
let's see. What kind of frameworks do you build on? Do you use Unity or like what's your game? What game engine? Or you said
I
Steam?
use Godot.
What's it called?
Godot. It's like
Oh, I see. I
Godot.
see.
Yeah.
Nice. And how long have you been outside of working from Amazon? Like when did you leave working the corporate world?
Around 2 years ago,
I see.
or actually, 1.5. Yeah.
Yeah. Why do you want to get back into it?
Game dev. You got to be like one in a million to get to the top, but
Yeah.
I wouldn't be opposed to making another game. But
Yeah, you could do it on the side too. Right.
yeah, but I guess it's kind of doing the same stuff for hobby versus work. It's a lot more draining. But
Yeah. Yeah. Cool. So you got into Amazon before, right? They asked
yes.
for some pretty hard interview questions. So you're
Uh,
pretty good then, I guess. Like from what I know, they asked some pretty hard questions.
yeah. It was. I mean, it was like one of my first major jobs out of college.
Yeah.
So I think they might have gone kind of easy on me. But
Hmm. Okay, cool. We're gonna start off with the first question then. Let's get straight into it. So we're pretty much given an array of routes representing bus routes, where routes I is a bus route that has the ith bus repeating forever. So for example, we're, this is the example right here, example one. The input is this. We're gonna be given a list of routes. Let's say this is bus 0 and this is bus 1 because that's the index. So for example, bus 0 follows these routes. It goes from station 1 to station 2 to station 7. Bus 1 and it just keeps repeating from 7 it goes to 1, right?
yep, makes
Keeps
sense.
repeating that forever. And then same thing with 3, 6, 7. So we're gonna be given start. We'll start at a bus stop, like at a specific bus stop. So we're gonna start at station 1. Our goal is to figure out from station 1, can we get to station 6? And
Okay.
we need to figure out the least number of buses that we can take to get there. So if we could just stay on the same bus, we can hop on one bus and get there. That's optimal. If we need to make a switch, that's fine. But we want to minimize the amount of buses we need to take in order to get to the destination. That's my explanation. Let me know if you have questions.
Okay. So yeah, we started at 1. We're trying to get to 6. So um, let me just read this again. So okay. So yeah, because 7 is in both routes, then you can basically change which route you're on through that. Um, and then yeah, so that makes sense because we're starting from 1. Um, Wait, take the first bus to. Wait, wasn't the. I thought the order was like bus 1 goes to 2 and 2 goes to 7 and 7 goes
Or
to
these
1.
are stations, not buses. So bus 0 passes by these stations.
Okay, so yeah, it's the number of buses we have to take, not um
Not the
okay,
amount of stations.
got it.
So the first strategy is take the first bus, which is bus 0, and ride it to 7. Once you ride it to 7, you can hop on bus 1 and take bus 1 to stop 6.
Okay. Let me get some clarification here.
Sure.
So, are all of the routes the same length? Like, could this have like 8 and 9 here, but this one still has only length 3? Like, is this allowed?
The Yeah, it's allowed. The
Okay.
amount of stops that a bus will stop at are different. Some buses will have a ton of stops. Some might have only a few.
Okay. Um, all right, so yeah, we're given the bus source that we start on, or no, the station, right? It's like this
Yeah,
1 refers to um
yeah.
wait.
Like for example, we can even have like a bus 2 here, and it could start at 1, but then it just goes to 10, then goes to 1, over and over. It's like we could get on here too if we want on bus 2. I think you're muted. Or
Okay.
does it make sense or no?
Yeah, yeah, I think that was a slightly different question you're answering. Like that was from the earlier one, but if we're like when we're at source 1, is this bus 1?
No, it's just station 1. So that means
Okay,
you could
yeah.
enter bus 2 or bus 0.
Okay, yeah. That makes sense. Okay, so some approaches that we could do for this. We can do a BFS um just to find uh the number of switches they have to do. It's not a totally straightforward BFS because for at station 1, um let's just say I'm trying to get to location 9. um it doesn't really matter that it goes from 1 to 2 to 7 to 8 to 9. It's like connected components basically.
Hmm.
So it's we can just map them all to the same group. So it's like we just have to do a BFS like between um different buses basically, like between the groups themselves, and not it doesn't matter within one group like
Hmm.
how many stops there is between them. Uh so connected components, we group each route or yeah, to one group, then do a BFS. So that's one approach we could do.
Group each
But
route into group. Okay, keep continue.
what was that?
Well, continue. Yeah, I
I,
was clarifying, or I was just thinking about something.
um, yeah, any other approach? Let's see. Some. I mean, you could do a DFS, but since we want the shortest path, we want to do a BFS, like breadth first search.
Hmm.
Um, yeah, I think I don't immediately see any other way to do
Could you
this.
just clarify and group each route into group? Like what data structure are we gonna store these groups in, and then like how are we gonna run the final query to be like, or run the final BFS on that? data structure.
Sure. So we could say we could use a dictionary if we want, or a set of some kind. So like the dictionary has a key which is the bus number, um, and the value is a set of the um like the stops that it has. So that the bus goes to.
Sure.
And from there, so if we're starting in this example at source 1, so we're here and we're trying to get to 6, then we can just loop through, or we can build a graph here and see like the shortest path from this group to each other node. So we do like, I guess there's only one like query for each of these, so we don't really have to do a pre-calculation and like cache everything. But I mean, we could do that. Um, does it make sense what I mean by that?
What do you mean?
So we can initially do like, we start from this group and we just save the shortest path to each other node. I guess, yeah, we don't have to like calculate for every single node the shortest path to every other node. We just care about the source and the target. And this is a single query problem. Like we're only asked about this one. If we were asked about like find the source from here to here, here to here, here to here, that's a huge list, then we'd want to do that pre-calculation. But since it's only this one, we can just like, we don't have to save all the results. Just we start here, and then once we see the target, since we're doing a BFS, that should be the shortest path to get there.
So when we're performing the BFS, what's gonna be in our like in our queue essentially?
Yeah. So we have all of the like we'll start with all the routes that are in our same source. So we could have each of these go to a map. Like for this example, we would make this into a set. Whoops. And to know which group it's in, let's see. There is like, I forget what this is called. I did this in a problem recently. You just make the lowest node be like the root, or like the master of this group. But we don't have to do that. We can maybe use some more memory here if we wanted. Basically with that.
Because here what I'm sets of stops that the bus goes to. Like
Yeah.
isn't this just this? This bus is telling you, well, just a list. But if we just convert this set, wouldn't just like this is we already have this data. Just bus num to like index 0 to the set of stops it hits.
Yeah. So maybe this is wrong. It should be like when I look up 8, I know all of the buses that it's connected to are in one step. So like let's see. Yeah, if I look up 1, then I should be able to get bus 0 and bus 2. Yes, because it's 0 steps from that. I'd have to think about this for a second. Yeah, so we're going from like the queue would have the starting station, and from there, you want to like start the queue with like all of these are 0 steps away, quote unquote. So yeah, so we just store the number of steps away that each one is. So maybe we can do that whole pre-calculation. So this would be like if we're storing the number of steps away, and this would be
This is your queue you're doing?
yeah.
Okay.
Oops. It would be like this and so on for all of these.
Okay, so all these are 0 away.
Yeah, because we're starting at 1, and then we also have to do that down here. So to know that 1 is connected down here, yeah, we need to invert this. We should be going from the station number to the oh yeah, I guess that is what this, or yeah, you want the connected component, so we need to know that like 1 is connected to 10 and 1 is also connected to all of these. So we could probably do an optimization later for that, but yeah, we can just have a separate grouping, or not exactly pointer type stuff, but that's the idea since these groups aren't changing. Like 1 would map to the group like 1, 2, 7, 8, 9, and 10 as well. And then it's the same for all of these. Like even 10 maps to that same thing. And same with all these numbers. They're all mapping to the same group.
1 maps to 1, 2, 7, 8, 9, and 10.
Yeah, because of this down here. Like this was added later in this example,
Okay.
but
these are all connected components, right? This is connected to this 1 through 7. So wouldn't this one just have all of them? This one.
So this was checking where the 1 was connected to.
Oh.
You're saying for 3.
1 is connected to just 10? Or
No, it's connected to all like 1,
okay,
2,
directly?
7, 8. Yeah.
Okay.
Does that make sense?
Yeah.
Or
that makes more sense. I'm just wondering. Yeah.
And then 3 would be connected to oh, not that group, just 6 and 7. And it's like 2 is connected to this whole group again. So there's some repeated information here, like we're repeating this entire set here. So that's when we can like reduce the group, which
But with that information, how do we like start like planning out or traversing towards the stop that we need to get to? Like
yeah, so if we're starting at 1, then we put all of this on the queue, and they're all 0 distance away. And from each of those spots, so like let's say we're starting at 1, let's see, we would mark all of the connected ones as seen. So I guess maybe we don't need all of that on the queue to start. Yeah, I'm gonna take that out. So yeah, the queue would actually start with this.
1 and 0. Okay, and then
yeah, it's the station number of steps that we've taken so far. And then so we go, like we would put all of these on the queue after that. So each of these gets added. We're missing the 10 at the end. But it would all be distance of 1 away. Well, that's still not true. If it's not already seen, then we can say it's a distance. Oh, yeah, this is.
Because
Yeah, if. Oh,
we want to
sorry,
do a
Will.
BFS, right? We want to do some sort of BFS, like you mentioned,
Yeah,
because we're trying to find the shortest path between two buses.
yeah. So, yeah, I think we can just we track all of the like when we visit one, we add everything in that connected component to the scene group.
Mm.
Um, so like when, oops, visiting, when visiting a station, to the scene set, and whenever we we would loop through everything in our connected components like that we haven't looped through yet, and once we do that, like once we're in a connecting component where we haven't seen those before, we add everything into the queue from that connected component with the step size of our current step plus 1.
Is the plan to, like, whenever we see the station, when we DQ a element and that's the station, we return like the amount of steps it took there?
Yes.
Okay, let me see. But what if pretend, okay, we could take this one bus, right? Take 7 and get off at 6. What if we had, this is bus, let's say 4, 5. We're gonna or sorry. One, two. Bus. Pretend we had bus here and it was bus 2, 6, 7. We had 7, 6 here. Or sorry, or 2 to 5. 5 to 3. Right. So we push all these into the queue, right? With 0. Then we push bus 1, 2, and 5 with 1. Since these were in the queue first, we'd probably push these into the queue next, right after. And then, essentially, I think with that solution, we would end up going from bus 0 to bus 1 to bus 2 to bus 3. If we're gonna push the stations onto the queue. Does that make sense?
Wait, you're saying if we start at 1,
Yeah, like
then
run your test on this now. Like this example. This is a harder example.
okay. So yeah, we're starting at 1, and or rather, uh, bus 1 maps to all of these still, which yeah, and bus 2 maps to that same group minus the 10.
Wait, bus 2, Matt?
Or station, sorry. uh yeah,
What about the
here.
5?
Yeah, 5. Yeah, and then same with 3. Yeah, here, this is station. Here, 2, Yes, this is like maybe I'm mixing up the terms here. It's the station to connected stations.
To connected stations. Let's see.
Like
Like if we started it at that station, these are the connected.
yeah, they're quote unquote 0 steps away. Like I don't have to
Okay.
transfer
Okay.
or yeah, I don't have to change bus. Oh, I see. Wait, I think I see what you're saying. So like yeah, if I was trying to go from 1 to 10 or
Or 1 to 6 still. There's two paths now. There's you go here and then you go here and then you go here. Or you can go 1 to 2 to 5
yeah,
to 3, then here.
so like as we search the places like through the BFS, if we've seen a spot, if we've been somewhere in more steps, like we always just set the amount of steps that it took to get somewhere to the minimum of its current value. So I guess we are still like exploring the whole graph in that case, which maybe isn't the best thing. Oh, does that make sense, or should I like kind of draw out what I mean?
Okay, I think if we try to BFS based on stations, it's not going to work. Um, because of like what I mentioned there. Here, let's go in the drawing. What essentially what we want to do is we want to find the minimum buses. So if we're gonna do a BFS, shouldn't the nodes be buses? B0, B1, B2. So pretend I want to go from station 1. Okay, what we have 0, 1, 2. Oh, sorry. 1, 2. We'll go like this. Like if we're gonna perform a BFS, shouldn't it be on the bus on the buses, not the stations? And the reason I'm saying that is, okay, we want to get to bus. This one. So what's the shortest distance? If we take from 1 to 7, right, and then we just go from like 7 to 6, we could essentially just take bus 0, and then like switch to bus 1 and then get there. What's the
Yeah,
other option? We can go from bus 0, ride it to 2, switch onto bus 1, ride bus 1 to bus 2, or ride bus 1 to station 5 and then move over to bus 2. And then afterwards like switch here. So this is one path and this one costs 1 and this one will cost 3, right? So
yeah,
I think you need to look at it in terms of like BFSing on the buses.
right. So yeah, we can just we start from 1 and we just append onto the queue, or rather because yeah, if we're starting from 1 and technically 10, yeah, we have to go through each one separately. Like the really naive way to do this, which might be fine. We just loop through all of these lists, and if it has our current spot, or if it has a 1 in it, um, then we append that to the queue. So like you we append all the spots that are like adjacent, like the bus stops connected here, like their bus number. So yeah, if we're starting from 1, then on the queue we would have bus 0, which is 0 steps, and bus 4, which is 0 steps away.
Hmm.
Which I guess let's see. Yeah, we would also want to like have the scene state as part of our queue.
Yeah, this looks good. Come onto the drawing again.
Yeah.
Like, how do we know if B0 has an edge to B3?
If there's a bus, if in this case, if 1, 2, 7, 8, or 9 connects to bus 3, which in this case, bus 7 connects to bus 3. Like, or rather, station 7 connects to station 7 in bus 3's route.
Yeah, like if they have a similar, if they have the identical station, like if at least one of the stations match between them, they have an edge. Like you can go from one to the other using that station.
Right.
So I think what we just need to work on is building this adjacency list where we just know what buses have edges to the other one.
Okay, so yeah, we have like bus to like connected buses, like, and that would be like you can use a map for that, like dictionary. So like 0 to it doesn't matter if we use a list or set, but I guess technically list is faster. So like bus 0 connects to we would just loop through all of the individual stations, and you could check if it's connected, basically. So station or bus 0. I mean, all the terminology is confusing here.
Yeah, this is the hard part of this question. It's just
So yeah, station bus 0. Let's see, how do we know if it's connected to bus 1? If it has 2, so like, yeah, the really naive way, you just go through each of the other lists, which I mean, we could just convert these to sets to speed things up a bit. Yeah, you just check like for each element. So like for this one here, is it in common with this one? Yeah, it is. So we append that here. And then we move on to number 2 here. So this one, we see that 2 is in common in bus 1.
what's 0 here?
It's the bus
Okay.
number.
Bus to connected buses.
Yeah, so like yeah, the 1 here was in common down here, so we put 4 on the list.
Sure.
Then 2 is here, 2 is visible here, so we put 1 on the list here, which, yeah, I guess this would be a set, so we don't have all the duplicates. Then same with 7. It's in common in bus 3, and so on, like this.
Yeah. Okay, build it out. Like, let's see what it looks like after, and then maybe we could reason about it. Like, what does it look like for bus 1 then after that? Or is there anything left there for bus 0 or no?
Yeah, there is more.
What's left?
Or rather, oh, there's not. Yeah, 8 and 9 are not in the rest. Although, let's see. Yeah, we don't want to add in itself here. Like, you don't want to say bus 0 connects to bus 0. Yeah, so we'll leave that out. And then 1. So bus 1, we check here. Oh, it's connected to bus 0 because they both have a 2 in common. So you put 0 there. And there's no other occurrences of 2.
So bus 1 only connects to bus 0. Doesn't it connect to bus 2 as well?
Oh, yes, you are correct. I didn't loop through all of them. So now bus 2 is connected to bus 1 because of the 5. There's no other 5, but there is a 3 on bus 3. And 3 goes to, let's see, there's a 3 on bus 2. There's no other 6, but there is a 7 on bus 0.
Bus 0. Yeah.
And here there is the bus 0 connection.
Yeah.
Okay, so yeah, with what you were saying, I think you drew the picture before we added in the additional buses, or
Or the drawing here? Or I think
yeah.
the drawing reflects what we have here. Without bus 4. Just ignored bus 4. I don't know. Do you see my screen?
I can see the drawing, yeah.
Okay. This is accurate there, I think. Or wait, let's see. Yeah. Isn't it? Like,
Let's see. 0, yeah, and then 1 connects to 0 and 2. So we need the connection here.
or I guess all of these are bidirectional. Let's just go with this.
Oh yeah, that works. Yeah, I think this is accurate now.
Mm-hmm.
Okay. So yeah, if we're going from 1 to 6, which the answer might not be accurate still. Let's see. So we're going from 1, we would whoops, up here. So we would have to have the station, like another map, which is station to bus. Or well, that's already what routes is.
Or routes only gives us bus to station, though, right? Not station to bus.
Oh wait, yeah, you're correct. So never mind on that part. Yeah, we would need station to bus. Yeah, we like. Should I build this out or?
Yeah, or let's just because we're almost at time. Just let's figure out how we're gonna do the BFS. Pretend we had this. We had the station to bus, so we could say from station 1, we could access like bus 0 and bus 4, right? How would we run our DFS or BFS if we have a queue here now?
Let's see. Wait, hold on. Was this accurate? Bus? Oh yeah. Wait. Station 1, 0, and 4. Yeah. Okay. So now we start from the station. So we would look up in station to bus, and we can put all of those on the queue at once. So bus 0. Whoops. I didn't mean to run that. Bus 2, or bus and steps is what this is. So it's 0 and 0 and 4 and 0 because it's our starting spot. And now we can search here. So when we pop, then we're getting these values. Here, q.pop.
What do we get first? 0 and 0?
What was that?
What do we get first then? 0 then 0 there? Or
Yeah. So yeah, sure. Whoops. It's 0 and 0. So now from here we have the buses to connected buses, which so we're at bus 0, and we have 4, 1, and 3 as the connected buses. We would also have a scene list here, and well, we haven't seen 4, 1, and 3 yet, but we would mark 0 as seen. And then we can go through all of those places. So that's 4, 1, and 3.
then what do we do? 4 and 3.
So we have the new buses, so we can append those onto the queue with like our steps plus 1. So like it would be something like this.
Do we want to push 4 into the queue?
So we like in the future, we know in the future we're gonna hit this. Or well, yeah, it actually this is what we want because we're doing breadth first search. So even though 4 with 0 is already in the queue, when we hit it the second time with this one, we're gonna see like, oh, this was already seen. So like, or is hit the second time will already be marked as seen, so we don't do the rest. Like we would do a continue part. Like already. Does that make sense?
Yeah, that makes sense. So what could you show me like the next iteration what the stack is gonna look like?
Yeah, so after we've gone through 4, 1, and 3, let's say, so this would have 4, 1, 1, 1, and 3, 1, because it's the number of steps away. So when we hit 4 here, then we go through. We mark 4 as seen. And we have our bus to connected buses. So we would, like we can check. It doesn't really matter whether we check when we're appending or since we have this part up here. I guess it might technically be better to have a check down here, but it doesn't make a huge difference, I don't think. Because it's like worst case, you'd end up hitting a lot of stuff twice. Well, maybe that's not true, but
Yeah. It could slow it down. Some questions it might TLE if you don't seen it at the right time. I
yeah.
noticed. But let's not worry about that.
Yeah. So you're hitting 4, so we append onto our queue 0, 1, and we'd already seen 0. That was the first thing we went through. And so now we're hitting 4, 1. That's already been seen before, so we're gonna ignore that.
Okay, pretend we go to bus 1, right? Bus 1 pops more things into the stack. Right?
Yeah.
Like, how do we know when to stop and return?
Yeah. So we're trying to get to 6, and we have station to bus. So we look up if the target is in station to bus at our current station, which we have bus to station, which is the routes stuff. So like for route in routes, target in station to bus. Oh wait, this should be like station. Or no, this is bus. Oh my gosh, station. We can just look through all the stations at our current bus. So, or yeah, so this is station.
Yeah.
If target is in, then like we return steps.
Okay. Cool. I think we're at time, but what do you think about the question?
Yeah, terminology was annoying, but yeah, it's a good problem. Just annoying to figure out what
Yeah.
actually needs to be BFS.
Yeah, I think I'll give you two questions that will be really helpful for like where you have to make these assumptions or where you have to do this kind of weird thing. And I messed this up in an interview once because I was messing with the terms as well. But I think one way to solve that is instead of just writing zeros and ones, like actually just do bus zero or like bus like prefix it, right? Because then when you're saying zeros and ones and stuff, it's confusing. Or you confusing yourself a bit too when it's like, oh, we're talking about buses or stations.
Wait, how is? Oh, you're saying
Or
just like
like
add these.
yeah, just
Add,
add like a prefix. Because when you're saying buses to connected buses, this makes sense because they're all buses. But what's here when you're like talking about stations? These are buses to stations. Like I feel like you're just mixing up a bit on that. Like between buses and stations, like you're mixing up like what you're operating on.
right.
Even when I was asking for you to describe what's in the map, like the key you would say is station or is bus, and it was like mixing it up a bit. And it's important to, and then yeah, does that make sense or no?
Yeah, just like
It's trippy. Have you tried this accounts merge question?
no.
Okay, try. I'll give you two questions. Try out this question that I asked you right now. It's called bus routes, and then try out accounts merge. These are ones where it's a bit more tricky than just a simple BFS. Because right here, I mean, you could maybe BFS on the stations, but I think with the way you mentioned it, it might return the wrong result. Like it might take the longer route.
Right, yeah.
But yeah, I think yeah, just understanding the main thing is just figuring out because you understand we had to do a BFS as well. But if you BFS on the stations versus if you BFS on the buses, like it's a slightly different solution. Like you can't BFS on the stations the same way and treat it like how we were BFSing on the buses. You have
Right,
to
yeah, you
do a
need that
slight.
extra layer.
You have to
Yeah.
add an extra layer of complexity or changes and different data structures like mappings. This one involves a bunch of different mappings, like you noticed too, with like station to bus, bus to connected buses.
Yeah.
It's tricky. Yeah.
Is this an actual problem that you said you saw something like it in an interview or
I got asked that accounts merge one. 721. That's a real interview question. This bus routes is a common Uber question, but people have been like it's pretty common. It's actually legit. But they'll give you the
Jeez.
whole time to work on the question. And if you've seen it before, you should be good. It's not like
Yeah.
impossible. It's more just like you just get tripped up on what we should BFS on or what we should DFS on.
Right.
Yeah. Yeah, try out accounts merge first, then try to get bus routes. But yeah, Cool. I'm gonna hop on with the next person. Thanks for taking the time out to come interview.
Yeah, thank you.
All right. See ya.